So, as I just said when I asked you to do these as warm-ups, the main thing that we are doing today is to solve trig equations by factoring them to figure out what our solutions are. So just reviewing a couple of our factoring methods as we begin, who can tell me how to factor this first one? X squared minus 4. What am I going to do on that, Katie? Excellent. X plus 2 and x minus 2. It equaled 0, so we can factor it. This was a difference of squares. So one method that we are remembering is we can factor one with a plus, one with a minus. So we get a negative 2 from one factor and a positive 2 from another, so that we have those two solutions. Okay, what about this other one? How do we factor this next one? It's equal to 0. Factoring only works if it's equal to 0, so we're in good shape to start. Luke, how do we factor this one? Yep, always remember, look for a GCF first. So this one we're going to have x times x minus 1 equals 0. So x is 0 and x equals 1. Don't forget, we also have the method for 1x squared plus something times x plus something equals 0. And we have the messier method when it doesn't start with a 1x squared. We have the AC method. We also have SOAP if it's the sum or difference of cubes. In addition, it's not factoring, but we do have that plus or minus square root method. And so I could have done this one with the plus or minus square root method if I said x squared is 4. So I have something squared equals. Then I can take the square root of both sides as long as I put the plus or minus in. And once again, I still have the x's plus or minus 2. So just wanted to have these in our heads as we get started on these problems. So here is our first actual example that we're going to do today. Tangent squared theta minus 1 is 0. We just have one theta. We go around the unit circle once. We're doing it in degrees. Which factoring pattern is that going to match for us? How do I factor that? It matches one of those two that I just had as a warm-up. Is there a GCF or a difference of squares on this one? Kevin? Difference of squares. Tangent squared, that's a square. Minus, so it's a difference. 1 is a square. So we can factor that with a plus and with a minus. Equals 0, so we were in good shape to do our factoring. That tells us that the tangent of theta can be negative 1, or the tangent of theta can be positive 1. We know that the tangent is positive 1 when we're in the first or the third quadrants. So when we are at 45 degrees or 225 degrees, we know that the tangent is negative 1 when we are in the second and fourth quadrants. So when theta is 135 degrees or 315 degrees. And then we write one final list of our answers in order. So 45 degrees, 135 degrees, 225 degrees, and 315 degrees. Give me a thumbs up, thumbs down in between. Does that example make sense? Now, to be able to do one less example today, I'm going to do this one another way. I could have, instead of doing it by factoring, I could have said tan squared theta equals 1. Everybody agree that's an equivalent problem? Now I have something squared equals. I don't have 3 tan squared, I just have tan squared, so something squared equals. So I could do that plus or minus square root method, and I would be back right here. The tangent is either positive or negative 1, so I would get the same 4 angles. Brand, you look puzzled. Question? Just modeling. That one you had a choice. It has to equal 0 to do the factoring. It has to be something squared equals to do the plus or minus square root method. So we could have rewritten this one either way. Okay, idea for this one. Think about those factoring methods that we had. We did an example with difference of squares. We did an example with GCF. And we said there were some other factoring methods as well. Which one jumps out at you for this one? Which factoring method are we going to use? What are we going to do on this one? We're going to do GCF on this one. So sine of theta is our GCF. We factor that out in front. Sine theta times sine theta is sine squared theta. And then a minus 1 equals 0. Equals 0. That's what we needed on the factoring. That's the only time it works. So either the sine is 0 or the sine is 1. Help me remember. Is sine the x or the y? It's the y. So the y is 0 on the unit circle when I am at these two places. This problem is degrees, not radian. So the angle would be 0 or 180 degrees for those two positions on the unit circle, where the y value, the sine, is equal to 0. The y is going to be equal to 1 if I am up at the top of the unit circle. That happens when I am at the angle of 90 degrees. Writing these answers in one list in order. Theta is 0, 90, or 180 in order, and each of them written with a degree sign. Questions on that? Okay, 2 more examples. Getting a little bit harder now, though. This one, I'm going to work 2 ways. I'm going to work it a tempting way that ends up not being correct, and then I will also do it the correct way. The tempting way, I look at that, oh, you know what? I've got the same thing on both sides. I've got a sine x on both sides. So I'm just going to go through and divide both sides by the sine of x. So I'm going to take 2 sine x cosine x equals sine x, and I'm going to divide each side by the sine of x. So I have 2 cosine x is 1. That means that just the cosine of x is a half. And I know that happens on my unit circle. Cosine's my x, needs to be positive, so I'm on the right of the y-axis, these 2 locations. So those angles are, doing degrees again, 60 and 300 degrees. And that's tempting. The problem is I divided by the sine of x. And one of the topics in this lesson was losing solutions when we divide. I divided by the sine of x, and what actually happened is I got some of my answers, but I lost at least one of them and maybe more because I divided. I can divide by numbers. I can't divide an equation by variables without risking losing a solution. There was a variable in what I divided by. So you can't divide by just x. You can't divide by 3x. You can't divide by x minus 4. You can't divide by the tangent of x. You can't divide if there's a variable in what you're dividing by. Or you might get some of the answers, but not all of them. So now we'll go back to this and do it a way that does not lose any of our solutions. So if I factor instead, I need to get it where it is equal to 0. So I have to do minus sine x to get everything on the left so that it equals 0. Now, which factoring method, everybody? GCF. So once again, we're going to factor the sine of x out in front. This time it happens to be times 2 cosine of x minus 1. So I have that the sine of x is 0, or I have exactly what I had before, that 2 times the cosine of x is 1. So the cosine of x is a half, and from the work that I just did, that gives me the 60 degrees and the 300 degrees. But the thing that I divided by, the sine of x, might have also been 0. That's the problem, because we can't divide by 0 without getting ourselves in trouble. Sine, we said, is the y-coordinate. We're talking about these two places on the unit circle. So we do have to also include the 0 and the 180 on this. And then we write our final list, one list, everything in order, 0, 60, 180, and 300, and make sure we remember the degree signs on each and every one of those. So give me a thumbs up or a thumbs down on that one. Is it making sense? So just be careful. Don't divide by something that has a variable in it. Okay, last example. It's going to be the hardest one. And I don't know about you guys, but I look at this and I go, oh my gosh, what in the world is going on here? I've got still degrees. Okay, that's not bad. But I've got these theta over 2's now. So that means I'm only going to be going to 180. I'm only going to be going halfway around the unit circle when I do this. And what the heck do I do with that? It looks like such a mess when I look at it. So take a deep breath and take a second look at it. I see secant squared. And I see just secant. Oh, I've got a quadratic. I've got something squared, and the next term is just that something. So it's a quadratic. So I'm going to do something to make it look more friendly to be able to factor my quadratic. I am going, since I've got secant of theta over 2 right here, and I've got secant theta over 2 times secant theta over 2 right here, I am going to do a substitution where x is the secant of theta over 2. Now, when you do substitutions, you cannot use whatever letter they've already put in the problem. So you may not use theta. Otherwise, I don't care if you use another Greek letter, if you use a letter out of the English alphabet, if you use a letter out of the Arabic alphabet, if you use a letter out of the Russian alphabet, just don't use theta. I'm picking x because it's nice and friendly and I'm used to it. But you could pick anything except theta. Then when I rewrite my equation, it is 2 times secant theta over 2 times secant theta over 2, that's just x squared, plus 3 times secant theta over 2 is just x, plus 1 equals 0. Are we good with that? That's the whole trick on this. Now, it's an Algebra 1 problem. You learned how to factor these in Algebra 1. It's not the easiest or favorite method. I'm going to review the AC method on it since it does not start with 1x squared. And then I'll talk about, yes, this one is so easy you could have done it with guess and check too. But I want to review AC method with you. That means we need two things that multiply to be 2 times 1. So they multiply to be 2, and they add to be 3. Who can tell me? Everybody shut up. What numbers multiply to be 2 and add to be 3? 2 and 1. We do not rewrite it as x plus 2, x plus 1. Not with the AC method. When it doesn't start with a 1x squared, those numbers tell us how to split up the middle number. This becomes a 2x plus 1x. So we have 2x squared plus 2x plus x plus 1 equals 0. GCF of the first two, in this case, is 2x times x plus 1. GCF of the last two is either plus or minus 1, whichever one will give me the matching parentheses. In this case, the plus 1 lets me have an x plus 1 that matches. So it factors as 2x plus 1 times x plus 1 equals 0. Yes, this one is easy enough If it started with a 2x squared, if you can factor it, you've got to have one that starts with a 2x and one that starts with a 1x. If it ends with a +1, you have to either have +1 and +1 or -1 and -1. So you could do guess and check and get those same two parentheses. Is everybody good with this factoring? Question? Because that's the AC method. If it does not start with 1x squared, you need two numbers that multiply to be a times c, or 2, and add to be b, which is 3. And then the AC method is you split the x term up using those numbers. If it had started with a 1x squared, that's when you can do the thing with two parentheses that start with 1x. But that did not match this pattern. And because I suspected we'd be kind of rusty on AC, that's why I wanted to talk through both ways on that one. But now we're all good with this factoring, right? That means that x might be -1/2 and x might be -1. But is x what's in our original problem that we're solving for? We really need to solve for theta. So now we have to go back and do our substitution and say x is really the secant of theta over 2. So the secant of theta over 2 is what's either -1/2 or -1. Okay, when we have secant, cosecant, or cotangent, we know we like to do the reciprocal of both sides to get it to something we know unit circle values for. So reciprocal of both sides. What is the reciprocal of secant, everybody? Cosine. And the reciprocal of -2 is, or I just gave it away, of -1/2 is -2. Where on the unit circle is the cosine -2? So start here and it's 1, and I go up to the top and it's 0, and I go over here and it's -1, and then I start getting back. Do I ever get over as far as -2? No, cosine is always between plus and -1, so that can never happen. So that factor gives no answers, no solutions. Reciprocal of both sides again. Reciprocal of secant is cosine. Reciprocal of -1 is -1/1. Cosine is -1 only when we are right there on the unit circle. So theta over 2 is our angle, is 180 degrees, which means theta is 360 degrees. And I want to go back and double check that restriction. Usually they say 0 is less than or equal to theta is less than 360, and I'm wanting equal to 360. So I'm going to look back at my restriction. Hey, I happen to be okay. This time they just did less than here. They didn't do less than or equal, but they did include the equal right here. So I am okay keeping that. And are there any remaining questions on this for today? Then we'll get busy with